Okay, third unit, assist device. So assist device is nothing but the device, electronic device which going to assist your organ for doing performance. Okay, when your organ fails to do the performance or it fails to function, at that time you will be replacing or assisting the work by inserting the device, electronic device, that is said to be assist device. Okay, so these are the assist device we are going to see, that is cardiac pacemaker, DC defibrillator, and then dialyzer, ventilators, magnetic resonance imaging system, ultrasonic imaging system. So these are the assist device we are going to see in third unit. So first we are going to see pacemaker, cardiac pacemaker. What is pacemaker? So pacemaker is nothing but an electronic device which going to generate artificial pacing impulse. That is artificial pulse. Okay, heart pulse will be generated with the help of pacemaker. Okay, so a device which capable of generating artificial pacing impulse and delivering them to heart is known as pacemaker system or pacemaker. So in the pacemaker, you will be having the device pulse generator and electrode. Okay, so pulse generator with electrode together called as a pacemaker. So pulse generator will generate the pulse, hot pulse. Okay, it means electric pulse. Electric pulse will be generated by the pulse generator. Okay, and then it will be provided to the heart as a artificial signal instead of your original signal, where the heart fails to generate the heart pulse or slow the heart pulse. Okay, so at the time you will be placing the pacemaker in your body as well as in externally and internally you can use the pacemaker. I think you all know what is the electrode. Transducer. Electrode is nothing but transducer which going to convert the biosignal into electrical signal. Okay, that for that purpose only you would be using electrode. Sinoatrial node. So sinoatrial node is nothing but a node which is present in the heart. Okay, in the left side of the heart, the node is present. That node will be responsible for heartbeat generation. Okay, so that's why it's called as natural pacemaker. Okay, so we are going to see the artificial pacemaker only, that is a device. But generally, you'll be having the natural pacemaker in your heart at the left side of the heart. That is sinoatrial node, which will be generating the heartbeat. Okay, generation of heartbeat is responsible for sinoatrial node. Okay, so when the sinoatrial node fails to generate the heartbeat or slows the heartbeat rate, at that time you will be using the pacemaker, artificial pacemaker. Okay. So there are two types of pacemaker. One is internal pacemaker and another one is external pacemaker. So what is internal pacemaker? So internal pacemaker is nothing but it going to be placed inside your body. Okay, so it will be implanted in your body itself. So it may be permanently implanted on the patient whose SA node, that is artery node, are failed to function, or those who suffered from permanent heart block. Okay, so heart block is nothing but heart attack. Okay, so the patient who is suffering from heart attack or permanent blocks in the heart will be placing the pacemaker permanently in the body itself. Okay, so internal pacemaker system are implanted with the pulse generator placed in a surgically developed pocket below the right or left clavicle. You will be placing the pacemaker in the left or right clavicle of your heart. Okay, So the exact location of pulse generator used in the internal pacemaker system depends on the following factor. So placing of pacemaker, okay, will depend some factors, that is type and nature of the electrode used. So what type of electrodes you are going to be used, okay, and then nature of cardiac problem. So what is the problem you are facing in the body or in your heart, okay. So based on that you will be you'll be selecting the location of your body. And then operation mode, pacemaker la there is more mode we will be seeing in the future class. So based on that modes you'll be selecting the place. So here you will not be having any external connection for the power. Okay. So here you will be using battery. Okay. Self-contained battery. So you will not be externally connected with your power. Okay. So no external connection, only internally it will be operated by using battery, okay, for a specific period. So frequently you have to change your battery, you have to go for checkup, okay. How they will be changing means they will be going for checkup frequently, okay, in a particular time period. And then external pacemaker, so this external pacemaker will be placing externally, that is outside your body. You can use the pacemaker outside of your body, it is not at all permanently implanted, okay. Temporary pacemaker, okay. So in case of temporary heart attack or mild attack, okay, at that time you will be selecting the external pacemaker to use. So it consists of an externally placed pulse generator circuit connected to the electrodes placed on the myocardium. So the electrodes will be placed in the chest, okay, that is outside of the body. In the myocardium means what? In the above surface, okay. In the chest you will be placing the electrodes. So temporary heart irregularities or disorder. So temporary heart attack, that is mild attack, okay. So in that case you will be using this type external pacemaker, treating the patient from arrhythmias. Arrhythmias, what is arrhythmias? That is nothing but irregular heartbeat, okay. Then treatment of coronary patient as well as during the cardiac surgery. So if you go for any cardiac surgery or coronary is nothing but a part in the heart, okay. So if you go for any mild surgeries you will be using external pacemaker. So cardiac pacemaker generally consist of pulse generator and electrodes, okay. So here we are going to place the pulse generator in the body and connected normally to the electrode with the help of wires introduced into the right ventricle, okay. Here in external pacemaker you will be using wire, but in internal you will not be using any external connection, but here you will be using external connection, that is through the wire only you are going to connect the pulse generator, okay, with your ventricles, right ventricles of your heart. So the pulse generator may be strapped to the lower arm of the patient. So where you will be placing the pulse generator means in the lower arm, okay, the hand of wrist or below the elbow, likewise, okay, there you will be placing the pulse generator. Types of pacing modes, so these are the types of pacing modes. Here you will be having more modes. So generally two major mode, that is competitive mode and non-competitive mode. So further your competitive mode is classified into asynchronous mode. Non-competitive mode is classified into ventricular or atrial programmed, okay. Ventricular or atrial program means you will be placing the pulse generator in the ventricular node, atrial node, okay. So ventricular atrial node is nothing but a node which is present in the heart. Okay. So under the ventricular programmed node, you'll be having demand mode, standby mode, standby mode. Demand mode means based on the demand of heartbeat. Okay, you will be requiring the pacemaker signal. You will be getting the signal based on the demand required by the your heartbeat. But standby mode means permanent. Okay, so constantly it will be providing the pulse to the heart. Okay, by the pacemaker. So what is synchronous, asynchronous? So asynchronous mode means you'll be fixing the speed rate of your heartbeat. Okay, that is heart pulse. Okay, you'll be fixing the pulse rate. So it will not be changed at all time. That rate, the same rate will be provided all in all time. But synchronous mode means, so based on the frequency and rate of your heartbeat generated in the uh, atrial node. Okay, that is natural pacemaker. Based on that, it will be providing the signal rate to the heart. Okay, that is synchronous mode. So cardiac pacemakers have certain modes of operation. And then ventricular asynchronous pacemaker, ventricular asynchronous pacemaker, ventricular inhibited pacemaker, atrial synchronous pacemaker, atrial sequential ventricular inhibited pacemaker. Okay, so first we are going to see the ventricular asynchronous pacemaker. Okay, this is one of the mode. So actually these are the modes of operation. Okay, so under the modes of operation, these are the topic. So first one is ventricular asynchronous pacemaker maker, which is a fixed rate pacemaker. So here the pacemaker going to be implemented in atrium or ventricle. You can use atrium mode or ventricular place. Okay, it is suitable for patient who are suffered by total AV block. What is AV? Atrioventricular block. Okay, so in the atrioventricular block means in the atrioventricular vessel, you'll be having block. Okay, so that is AV block, atrial arrhythmia. Okay, so in that case you will be using or you will be selecting the ventricular asynchronous pacemaker mode. So here the square wave generation. Okay, so square wave generator and monostable multivibrator circuit will be used for generating the heart pulse. Okay, square wave generator will generate square wave only. So square wave is nothing but pulse. Okay, so pulse is nothing but square wave. So monostable multivibrator also will generate the same pulse, that is square wave. Okay, so these two types of generator will be used for this type of pacemaker. So the output of this combination provides a positively and negatively going square wave with equal duration of for positive and negative pulse. Okay, the output of this generator will have both positive and negative waveform. Okay, so that positive and negative waveform will have equal duration. And then the period square wave generator is given as t. So timing denoted as t for the square wave. So t equal to minus 2 into rc ln into r3 divided by 2 r2 plus r3. So timing or time rate for the square wave. So you can change the time rate by changing the resistor and capacitor value present in the circuit. There is generator circuit. Okay, generator means only generator you are not going to use. So in the generator you will be having transistor, resistors, etc. Okay, square wave circuit and your monostable multivibrator circuit. EC students will know, I think. So multivibrator is nothing but you will be having the two transistor with the help of resistors and capacitors connected. Okay, so resistor, capacitor connected with transistors only will called as a monostable multivibrator or square wave generator. Okay, so the presence of resistor and capacitor only, or the selecting the value of resistor and capacitor only will give the pulse rate, it is signal rate or speed rate or heartbeat rate. So this is the circuit. See here, op amp, we are going to use op amp. Ma'am, you said transistor, but here they used op amp, means that is nothing but IC, op amp and IC, integrated circuit, operational amplifier IC. Okay, integrated circuit. So your integrated circuit is made up of transistors only. Uh, Op amp with the help of resistor, capacitor only, you are going to design the entire pacemaker. Okay, so by selecting the value of resistor, capacitors, you will be changing the heartbeat rate. Okay, next, ventricular asynchronous pacemaker mode. This is also a fixed rate pacemaker. So, so here in the first mode, you will be having the competition between the natural heartbeat and pacemaker beats. If the pacemaker impulses reaches the heart during a certain period, ventricular fibrillation may occur. So ventricular fibrillation is nothing but, what is fibrillation? Shocking will be called as the fibrillation. Okay. So nowadays the fixed pacemaker is fabricated on a large scale integrated circuit. So with the help of IC, you are going to design the pacemaker, that is fixed pacemaker, that is internal pacemaker. Okay, for the patient. So disadvantages of ventricular asynchronous pacemaker is, here the heartbeat rate cannot be changed because it is fixed rate. Okay, if it is fixed in atrium, that means, ma'am, you said that here by changing the resistance value, you can change the heartbeat rate. This can be changed before placing your pacemaker in the body. Okay, internally in the body. So if before that you can change the circuit, but after keeping the pacemaker in the patient body, you cannot change the heart rate. Okay, ஸோ சர்ஜரி பண்ணிக்கிட்டே இருக்க முடியாது, சும்மா சும்மா பண்ணி பண்ணி சேஞ்ச் பண்ண முடியாது. ஸோ பிஃபோர் டூயிங் த சர்ஜரி யூ கேன் சேஞ்ச் த ஹார்ட் பீட் ரேட், பட் ஆஃப்டர் டூயிங் த சர்ஜரி யூ கேனாட் சேஞ்ச் த ஹார்ட் பீட் ரேட். ஓகே, இட் இஸ் ஃபிக்ஸ்ட் ஹார்ட் பீட் ரேட். ஸோ இஃப் த பேஸ்மேக்கர் impulses reaches the heart during a certain, இது சொல்லிட்டேன். If it is fixed in atrium, atrium beat at a fixed rate. If ventricle beat at a different rate, and then it leads to a severe problem. So here we are going to place this type of pacemaker in the atrium. So I think you all know the parts of your heart. So there is atrium, ventricle. Okay, so atrium beat have to match with ventricular beat. If it is different rate, means it will be leading to a severe problem. So there may be occurrence of ventricular fibrillation. Okay, Next, ventricular synchronous pacemaker mode. This is standby mode. Okay, this is used for patient with only short period of AV block or bundle block. This type of pacemaker is used for temporary period. Okay, those who are suffering from AV block, they will be using this type of pacemaker. So this type does not compete with the normal heart activity. So it will not have the um, it don't want follow the normal heartbeat. Okay, so just for temporary case, you will be using this ventricular synchronous pacemaker. So a single transverse electrode will be placed in the right ventricle sense or wave and delivers the stimulation. I think you all know the waveform of your heartbeat. Heart pulse or waveform தெரியும்ல PQ or S. Do you remember? In ECG you learnt in that R wave. So that R wave will be sensed by the electrode which is present in your ventricular synchronous pacemaker. Okay. So here it going to be stimulated by the pacemaker. So this is the circuit or circuit, not circuit, block diagram of ventricular synchronous pacemaker. So here you will be having amplifier circuit, filter circuit, refractory period control and timing circuit. This is timing and control circuit. Okay, fixed rate pacemaker and then output amplifier. So two amplifier, one is in starting at another one is at the end, and then filter and then control and timing circuit, and then another one is pacemaker, that is generator, pulse generator. Okay, here you will not be having separate sensing electrode. Okay, so here R wave triggers ventricular synchronized pacemaker which provide an impulse falling in lower part of normal QRS complex. That means R wave will trigger. Trigger means it will boost. Okay, just it will activate, initiate. Okay, initiate your pulse which will be fallen in your QRS waveform. Okay, so atrial generator ventricular contraction generates R wave. Atrial generated ventricular contraction. That means atrial and ventricular. Atrial will generate the ventricular contraction. Okay. Contraction means it will be emptying your ventricular node. Okay, ventricular part to generate the R waveform. Impulses which will be provided after ventricular contraction. Okay, uh, after ventricular contraction only you are going to generate the impulse. Okay, that means after after contracting your ventricular part only you are going to generate the impulse. Okay, that is impulse is nothing but pacemaker generating square waveform, that is impulse. So how it is working? So using the sensing electrode, heart rate is detected and is given to the timing circuit in pacemaker. If the detected heart rate is below a minimum level, the fixed rate pacemaker is turned on. If natural contraction occurs, asynchronous pacemaker timing circuit is reset so that it next pulse will detect heartbeat. So here we are going to use the sensory electrode, okay, which will be sensing the heart rate. That means it will detect the heart rate that will be given to the timing circuit. Okay, timing circuit is this one. So after detecting the heart rate, it will be amplified and filtered and then given to the timing circuit. So if the detected heart rate is very low, That means normal heart rate விட கம்மியா இருந்துச்சுன்னா you will be turning on your pacemaker. Okay, so that pacemaker will be giving providing the heart rate, I mean heart pulse, okay, to the heart. So otherwise, asynchronous pacemaker produces at its preset rate. The pacemaker may detect noise and interpret as its ventricular excitation. This can be eliminated by refractory period or gate circuit. So sometimes you will be having some noise and interpreting signal in the ventricular node. So that will be eliminated by refractory period. Refractory period is nothing but that small period which will be taking for accepting the pulse. Okay, there is to be refractory period. So in that period it will be eliminating the noise signal. Okay, all the noise signal will be filtered out in hot block P waves with respect to ventricular excitation. So here the blocks which will be occurring in the P wave will be taking responsible for ventricular pacemaker. Okay, so the blocks in P waves can be cleared by pacemaker, ventricular pacemaker, that is standby mode pacemaker. So P and R waves have different frequency band. So the high pass filter completely eliminates P wave and R waves. Input amplifier increases peak to peak amplitude of R wave. That means the filter which is used in the circuit will be used for eliminating the P and R waves. Okay, so P and R waves will be having low frequencies. Okay, here we are going to use high pass filter. That means it will pass only the high frequency signals. So the low frequency signals will be removed in the high pass filter. So P and R waves are low frequency signals, so it will be removed completely in the high pass filter. So the input amplifier, the first amplifier which is used in the pacemaker, will increase the peak to peak amplitude. That is, amplitude value will be increased. So advantages of ventricular synchronous pacemaker is here fibrillation in the before mode. It is fixed rate mode. You will be using the ventricular fibrillation. Okay, but here there is no need of ventricular fibrillation. Here, when your R wave is normal, the fixed rate pacemaker block is not in on condition, so power consumption is reduced. So R wave normal இருக்கிறப்ப you no need to use your pacemaker. When your R wave fail to generate, that time only you are going to use the pacemaker. Okay, so automatica it will be oning and offing. Okay, on and off will be done automatically by your pacemaker. Okay, by detecting your R wave with the help of reference R wave signal, so that the power consumed will be reduced. Then disadvantage in patina, here the EMI interference will be very sensitive, or detection of EMI signal will be more. And then synchronization between atrial and ventricular contraction is failed. Okay, there is no synchronization between atrial and ventricular contraction. These are the two disadvantages. So demand pacemaker நாளைக்கு பார்க்கலாம்.